Hey there, hi there, ho there, and welcome to another fun day of math with Bartlett. I'll be your host, Bartlett, and today we are in week 6 of our stay at home order, and we will be doing more, and we're going back to the coordinate plane. So, a couple of assignments will be on here. One is on Delta Math by popular request, and the other is on is going to be an Edge Elastic quiz. So, hopefully, this all finds you well. A couple quick reminders before we get into everything. We're going to be talking about an equation of a line, so that's going to involve y equals mx plus b. M is our slope, as always. B is our y-intercept. And you guys have worked with these for the better part of 2 years at this point, so this should be no big shock to any of you. The other thing we've got, and this is the new kid on the block, is the equation of a circle. Now, the equation of a circle reads more like a quadratic. It's got an x minus h quantity being squared, y minus k, that quantity is also being squared, and it equals r. Hey, that quantity is squared too. Couple quick things on that. About a circle, we know that important things on the circle tend to be the center, and that's going to be the point at h comma k. H and k are here and here. Do notice that the minus sign is part of the equation, and we use the not minus sign version for our center, and we'll talk a little bit about that in the examples. The radius is r, and if you have this here, you just have to take r squared, square root it, and that's going to give you what you're dealing with. So we'll talk about how that's going to work its way through and what's important there. But first, a few examples. We'll start off with graphing this line. Now, I'm working on Notability. I'm going to input the answers in Delta Math. These are all screenshots from Delta Math to hopefully give you guys some ideas here. So I'm looking at y equals 3 halves x plus 1 first off. And this, of course, is following our y equals mx plus b format. That means that m, our slope, is negative 3 halves, and b, our y-intercept, is 1. That gives us the point 0, comma 1. Now, I know it's been a little bit since you guys have graphed lines. That's why we're starting here first. And graphing our lines, first thing that we're going to do is plot our y-intercept. And so we'll plot that right at 1. The second thing we're going to do is, from that point, that y-intercept, follow slope. So from here, I'm going to use my highlighter. We're going to follow a slope of negative 3 halves. That means I'm going to go down 3 and to the right 2. So we'll start here. I'd like that to be a little smaller for the sake of so you guys can see. And we'll go down 1, 2, and 3 units down, and we will go over 1 and 2. That gives us our location for the second point. Third idea, pretty straightforward. Connect the dots. I know they're formally called points. I have done this for a while, but hey, connect the dots was my favorite thing to do when I was about 5 years old, 6 years old, in dealing with numbers in that context. So there is slope, and there's the equation of a line. This is all you have to do. Your first question set on this will have you, I'm a couple ahead, will have you graphing with that equation, and it's the same clicks. So you click at 0, 1, you go down 1, 2, 3, and to the right 2. Here's your line. Click there, submit, verify, wait for the blinky dot to go away, and you should be in good shape. We'll go ahead and get this scrolling while we wait for that. So I'm asking you guys in your second problem, let's see if that's ever, this may never, load. But I'm using a lot of bandwidth for all this right now. Let's talk about slope-intercept form, but coming from the equation. So I'm looking at y equals mx plus b as my base. So I want to do two things. First off, I want to find b. Remember, that's the y-intercept. Of course, the y-axis is this one that goes straight up and down, as indicated by the y. And the reason this is all called the y-intercept is because that's where we intercept the y-axis. So -6 here. So that's going to give me a coordinate 0, -6. Item 2 we're going to do is we are going to find slope. Now there's equations, there's all that sort of stuff, but let's not reinvent the wheel. I'm going to come a little bit over here. Ooh, that zoomed a little more than I wanted. But all we're going to do, this goes down 1. We'll use the triangle method. We're going 1, 2, 3, 4. So we're going to the right 4 units. So that means our slope is rise. Whenever we go down, it's negative. Run is 4, so our slope is 1/4, giving me a final equation at y equals -1/4, that's our slope, x from the equation, plus -6. We can also just write that as -1/4 x minus 6, and that's a perfectly fine equation there. Hopefully, example 1's gone through. Maybe someday. Like I said, I'm using a ton of bandwidth, but I have all these pulled up for you guys beforehand so that we can go through them. So to do this, it's just going to be y equals -1. Now, I know your keyboards don't have an ABC button or a division button or anything like that. All you got to do is hit the divide, hit that backslash right next to shift, or if you got a number pad on there, 1/4. Make sure you hit the arrow to get out of that. That part's going to be super important. You can't be down here. It will mark it wrong. You got to come out. X minus 6, and maybe this one will have a little bit more bandwidth to it, but we might just be unblinking. Hey, you guys get the picture here either way. App reloaded me entirely. Probably not going to get to verify any of the answers on these, but I think we'll live. All right. Determine the equation of the circle graph. Now, I've got 2 sets where you're working with the circles. The first one, what you're going to have to do, you may have to sketch some graphs down or do some on-screen looking, but easiest way to go about this, these ones are set up to be pretty simple to figure out for you. I've got a top, a bottom, a left, and a right. These ones are going to set up to where they're pretty easy to figure out. So I've got a point. I'm going to do a little bit of labeling here to show you guys the common denominators. Once you get it, it'll be a little faster to do all this for you. I'm looking at a coordinate here at 6, 3. I'm looking at up top. I've got 2, 7, or yeah, 2, 7. I'm looking off to the right at -2, 3, and I'm looking down at the bottom here at 2, -2. I hope you guys remember lines that go vertically up and down are x equals lines. Our lines that go horizontally, that's right to left, are y equals lines. Now this won't work on all circles. At times you'll have to get a little bit more information provided for you, but this particular set of examples, this is going to work out just fine for you. I'm going to take the x value here and my y value from my y's, and my center of the circle is going to be at 2, 3. Now I know I jumped a little bit on that. I wanted to get straight into that because to me that is the meat and potato of the hardest thing in this equation. I am looking at an equation of a circle. Now this was the new guy for this week. We have x minus h squared plus y minus k squared equals r squared. There are 2 important parts to this equation of a circle. That is the hk, and I think you guys, we've worked with r enough, I think you guys can recognize that r is going to be the radius, and we talked about that a moment ago. But the center is at our point h comma k. That's super important because we just found this, h, k. So I have got right now x minus, well, h is my x value, so x minus 2 squared plus y minus, hey, that's there, 3 squared. The radius, I just find that by going, well, this is 1, 2, 3, and 4 long, 4 squared. Do not forget to make that actually square out. So that's going to be 16 there. This is your whole answer. X minus 2 squared plus y minus 3 squared equals 16. Remember, this is the base level of the circle. This is where I'm asking for the least and the simplest sort of information, just to get the flow of the equation. Don't try making this overly complicated, over difficult here. Use your kind of crosshairs method, find the center. It'll be very straightforward through here. Also, don't forget, of course, you have the extra references from our good friend, Mr. Delta Math. All right. I wanted to take you guys through a distance formula. We've done this. I feel like we've done this a million times this year. I'm sure some of you guys do as well. x2 minus x1 quantity squared plus y2 minus y1 quantity once again being squared. If you are a person that struggles with where to put everything, please make sure you go through and do your labeling. We'll call this x1 and y1, x2 and y2. Yes, you do have to write it down. You should be doing all of these problems with paper and pencil, I would hope, because they all involve calculation. None of them can be done straight on the screen, and none of them can just be done directly in a calculator. I need to look at plugging stuff in. So my x2 I've got as 5, so this is 5 minus 9 squared plus negative 3 minus 3 squared. I very strongly recommend doing at least one step before you put in the calculator, and that is your subtraction step. It's just going to save a lot of issue there. Make sure you got a parenthesis in. This should be negative 4 being squared, and negative 3 minus 3 is actually 0 squared. Big key here. Sometimes this happens where you cancel out part of it. That's fantastic if that happens. If it doesn't, it doesn't. Wait a minute. I made a mistake. I'm sure you all saw it before I did. This is negative 6 squared. Just had one of those brain moments. Either way, you can put this in the calculator at this point. Remember, when you square, it should make it positive. That's going to give me 16 here, 36 here. I would probably run straight to my calculator at this point. But 16 plus 36, that gives me 52. We're being asked to put this into radical form. Now, radical form is when you're looking at a situation where you have a square and a not square, stuff under a square root. So I'm going to walk you guys through that very quickly. What you want to do here is we're going to talk about, for a second, perfect squares. These are where we've got 1 times 1, 2 times 2, 3 times 3, numbers times themselves. So things like 1, 4, 9, maybe 16, 25, 36, 49, and so on. So I need to split this up into factors. That's 2 numbers to multiply together, and I need one of those 2 numbers to be a perfect square. Looking kind of at what I've got contextually, I know that halfway is going to stop at 25 because 25 times 2 is 50. 25 is probably not going to go in, but I know I'm not going to need to go any bigger than 25 because there's nothing that would multiply by that. So we're going to take a look. 1's not overly helpful. 4, 9, and 16. Going over to our nice, happy Desmos calculator. 52. I'm going to look at 52 divided by 4, and that gives me 13, which is exactly what I want. So I'm getting the square root of 4, because all this is still under square roots, square root of 13. 4 times 13 is 52. Square root of 4 times square root of 13 is the square root of 52. The deal here is I can simplify the square root of 4. The square root of 4 is, of course, 2. So this lets me get 2 times the square root of 13, and that is done. And yes, y'all do have to input that answer directly. You're going to be fine. Last, but certainly not least, I have determined this equation of a circle graph below based on my equation of a circle, and I'm going to have to use the distance formula here. All right. So quick look at at our circle equation. I'm looking at x minus h squared plus y minus k squared equals r squared. My center is this, negative 2 comma 2. So I'm almost done with the whole thing. X minus negative 2 squared plus y minus 2 squared. I just need a radius. So make sure you get the first part before you do anything else. I do have to use the distance formula here because I need to get this length right here. Distance formula, you guys know this. We've done this literally the problem ago. We'll go ahead and plug that straight into our distance formula. Square root of, it doesn't matter what order we go into, I'm going to go with, call my x2 0. So 0 minus negative 2 squared plus, looks kind of similar, doesn't it? I'm looking at, I did 0 first, so we'll do 6 minus 2 square that. Plugging in and going, 0 minus negative 2, as you know, minus a negative, we can switch that to plus a positive. That gives me 2, make sure we're in parentheses squared, just good habit to be in, and then 4 squared. Simplifying on down, I've got 2 squared is, of course, 4. 4 squared is 16, and that gives me the square root of 20. Now, a lot of times you will see, and just in the problem before, we had to simplify this. For the circle, don't worry about it, because we're about to cancel it out, and I'm going to show you how that works. Going down, we're just going to take our equation from up here and copy it back down. I'm going to make it a little bit bigger so you guys can hopefully see a little bit better my work on this one. We're going to switch this to x plus 2, minus a negative as always becomes plus a positive, plus y minus 2, also squared, and that's going to equal our radius, which we just found to be the square root of 20, and that's getting squared. Final equation is going to have x plus 2 squared in it, plus y minus 2 squared in it. When I square a square root, that's like multiplying something that's half by 2. If you have 2 halves, you have 1 whole. If I have the square root and I square it, it just comes out as that whole number. So I'm just going to get 20 here. So final answer, x squared, or x plus 2 quantity squared, y minus 2 quantity squared equals 20. Make sure we plug that all in directly as is. And that's just going to go in down here. You may want to bring up the keyboard to help you out with this one. Parentheses, x plus 2, and you can use your keyboard for some of it. At least bring that up because you're going to want the squared, plus y minus 2 squared, and that's going to equal, make sure you hit the equal sign in, 20. Maybe it'll load fast enough today for us to get to in this video. Hey, it did. It'll show you a little bit of information. Remember, the videos are there. All the show the work is available for you. The notes are available. Check this all out and see me during office hours if you have any questions. Those are from 2 till 3, and I'll be doing another lesson at 2 o'clock or at 3 o'clock today. Thank you all for playing along. Sorry for my clicks. Have a